Okay, for this chapter 9 notes, at the end of the notes, I think the last, um, here, CQD, yeah. From here, they are all past paper questions. ف I'm gonna record all of it. If you want to, I'm gonna leave at the bottom or in description or wherever the timestamp for when I start the past paper questions because I'm 100% sure one of these will come in the written. Yani one of these graphs, one of these past paper questions. Okay. ف anyway, let's just start. Okay. How is the rate of reaction defined? It can be the decrease in the concentration of a product. No, obviously not. If it's product, it should be increase in the concentration because it's being formed, not decreased. Decrease in the concentration of product per unit time. No, it's the increase in concentration of product per unit time. Yes, it should always be per unit time. Yeah, and the decrease in the concentration of reactants. Since it's the reactants, we say decrease. Fine, this is also correct. Okay, it has to be per unit time. CQD4, calcium carbonate and hydrochloric acid react. Choose the most suitable method to determine the rate of reaction. You have a carbon dioxide gas being produced. Since you have a gas being released, that means the best way would be to measure the volume of the gas. Okay, so it would be the change in the volume of the carbon dioxide gas with time. Then question 5. Calcium carbonate and hydrochloric acid react as shown below. The mass of the apparatus used and its contents is placed against time. Choose the graph that shows what happens to the mass in time as calcium carbonate reacts to the excess acid. أكيد, I mean, it should be this one, unless I'm wrong. Uh, where am I now? CQD5 صح? ماشي وين CQD5 is it? Okay, hold up. Oh shit, hold up. It's gonna be B. Yeah, because okay. They said the mass of the apparatus. The apparatus is the beaker. Okay, look, we have carbon dioxide gas being released. Okay, so we have all the gases being released. So akid, the mass of this beaker is gonna begin to decrease. Okay, so it's wordplay, guys. Please pay attention to the question. I think they'll get something like this. I think they got this one in the periodic. I remember. CaCO3 and hydrochloric acid react as shown below. Here you have carbon dioxide gas released. Okay, which diagrams would be suitable for studying the rate of this reaction? I think it was this one. Okay, you're gonna need cotton wool. Okay, so the carbon dioxide can be released. Okay, and it's a balance as well because you have a solid, the mass is decreasing. Let me check. It's 2 and 3. Okay, I just asked the group. Um, Apparently in the periodic they asked you which is most suitable for studying the change in mass. Obviously the change in mass would be the one with the balance. This is correct also if you're speaking generally this would also be correct لأنه it has a gas syringe to collect the carbon dioxide gas, so that would also be correct. And they have this stopper over here to stop the carbon dioxide gas from going up. So it's either if you want to put cotton wool, you don't put a gas syringe. But if is with a gas syringe, you have to put a stopper to prevent the carbon dioxide from going all out. So it only goes inside the gas syringe, if you get what I mean. But anyway, these are both correct because they both can. This one measures the rate by studying the decrease in the mass of the reactants, and this one measures the rate by studying the increase in the concentration of the product of the gas released, which is carbon dioxide. If you can get, if you get what I'm trying to say. CQD. Okay, which of the following affects the rate of a chemical reaction? Concentration of reactants, akid. Pressure of the gaseous reactants, yes. If they said solid or liquid, no. Surface of contact in case of heterogeneous, I think this is correct, yeah. Surface area. Temperature, akid. Nature of substances reacting, akid, yes. Catalysts, yes. All of the above, yes. Okay. Nature, whether solid, liquid, or gas. Let me double check. CQD1, G, yeah, all of the above. Okay, what are the factors that affect the rate of a chemical reaction? How do they affect it? Well, they're here. But let's check the answer. Okay, CQD 14, 14. Where's 14? Okay, factors that affect concentration of the reactants. Oh, you have to explain each one. Okay, I think we could get something in the written like this. Uh, how do they affect? If you were to increase concentration, okay, it would increase the rate. Okay, okay, yeah. Increasing concentration increases the rate. Increasing pressure in the gas increases the rate. Increasing temperature will increase the rate. Increasing surface area will increase the rate. Addition of a catalyst increases the rate. Blah 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 blah. Okay, but these things, I think they'll get this. You know, how does increasing the concentration of a rate, how does increasing the concentration of the reaction of the reactant, uh, affect the rate? Okay, you would say increasing the concentration would increase the number of particles, uh, in a given volume. Okay, increasing concentration increases particles, like the red. Write down the red stuff. Increases particles in a given volume. Therefore, they will collide more, so the number of collisions will increase and rate of reaction increases. You have to write this, okay? Always, always, it has to do with the collisions, okay? They said it here in a collision theory. You might get this also. What is the collision theory? For reaction to proceed, they have to collide, okay? And when they collide, they have to have activation energy, okay? Okay, these are called effective collisions if they actually collide with activation energy. To increase the rate, it's required to increase, if you want to increase the rate and you want more collisions, right? So you need to increase the frequency of effective collisions, okay? طيب, moving here, SQD 18. So over here it shows higher concentration, lower concentration. Okay, be careful. Okay, if they said increasing the concentration of the excess. Okay, let's say they said we had a reaction between hydrochloric acid and sodium chloride. Okay, and they said that HCl, hydrochloric acid, was the excess, and then they said we increased the concentration of hydrochloric acid, which is the excess. How would the graph look? It would look like this. It would just have an increased rate, but it would have the same end product. Okay, CQD 18. What is the effect of increasing the concentration of reactant on the rate of a reaction? Justify your answer based on the collision theory. So you have to explain. If you increase the concentration of reactant, then the rate of reaction will increase. Because when you increase the concentration of the reactant, there will be an increased number of particles in a given volume, thus there will be an increased frequency of collisions, therefore the rate will increase. Let's check CQD 18. Increasing the concentration increases the rate of reaction because they will collide more often and more strongly, which leads to more effective collisions. If you mention anything to do with collisions that makes sense, you'll get it correct. Okay. Consider two gases A and B. What effect will the following changes have on the rate? The pressure is doubled. Okay. Obviously, if the pressure is doubled, the rate will double. Okay. Number of molecules of gas A is doubled, so yani, the concentration is doubled. So أكيد it will double. The temperature is decreased, it will decrease, right? The rate. Let's see what question 22. To double the pressure. Okay, 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 okay. They said explain. No, I just wanted what effect. To double the pressure means to add, decrease, add. Okay, this means the frequency increases. Okay, increase in the rate. Yeah. Doubling the number of molecule. Okay, increase in the rate. Okay, and then decrease in the rate. Yeah. Question. Okay, wow. Where am I? CQD 16. What is the effect of increasing temperature on the rate of reaction? Increasing temp. They want the explanation. Okay. Let's see. Increasing the temperature will increase the average kinetic energy. Therefore, there will be more particles that collide with an activation energy. Wait, what? The number of particles that collide with activation energy will increase. Yeah, so there will be more particles that collide with activation energy. Thus, the number of collisions increases. Okay. A second, not as important effect is an increase. Okay, forget about this. Okay, we should know effect on changing temperature increases average kinetic energy. Okay, therefore they will move faster. Therefore there will be more particles that collide with activation energy. Okay, because they have more energy, more kinetic energy, and they have activation energy. They're closer to the activation energy. Okay, so that means there will be more effective collisions, so more rate. Okay, so CQD 16. Okay, increasing temperature increases rate because particles move faster, so they collide more often. Okay, which leads to more effective collisions. As particles move faster, blah 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 blah. Okay, yeah, it would be good to mention that they will have activation energy. More particles. It would be good to mention that there will be more particles that have activation energy because they have higher temperature will lead to an increased kinetic energy. Well, when magnesium ribbon reacted with dilute hydrochloric acid at room temperature, the total volume of hydrogen produced was noted every 20 seconds. The results obtained are given in the graph labeled C below. Which of the following would happen if a leakage of gas occurred? Akid, if it leaks, then it's going to be the least, so E. Okay. Uh, Only half the magnesium ribbon has been used as compared to the original amount used in C. So obviously, if we're using half, so 60, half of 60 would be 30. So we go to 30, and it's going to be D. So here, D. Slightly warmer excess acid has been used. أكيد if it's warmer يعني the temperature will increase, that means average kinetic energy will increase, that means there will be more particles with activation energy, that means the rate will increase. So which one has a higher rate here? It will be B, right? C, higher rate than than C, it will be B. Let's put B. A greater mass of powdered magnesium ribbon has been used. If it's greater mass, that means it's a greater concentration. That means increased number of particles. That means there will be increased number of collisions. That means higher rate and more product formed. So A, because we're increasing the concentration of the limiting. The limiting in this case is magnesium. They said the excess is the hydrochloric acid. Okay, what was the final volume obtained in experiment C? I don't think any. This is hard. Go to C, 60. Okay, I think this question came in the periodic. Okay, blah blah blah. Okay, ooh. Which mixture will produce the slowest reaction to take place between solid barium carbonate chips and dilute hydrochloric acid? So which one has the worst conditions? Okay, low temperature, large chips. So far it's bad, bad. Concentrated acid, high concentration, no. Okay, low temperatures, large chips, dilute acid. Dilute يعني low concentration. Do we want that? I think, well, for now, yeah, that's the slowest. High temperatures, لا, that's fast. High temperature, again, fast. High temperature, again, fast. There's only one that's all bad, and it's the low temperature, because they want it to be the slowest reaction. Okay, exercise 2. Iron reacts with HCl to form iron chloride and hydrogen gas. 2 grams is added to 100 centimeter cube. Which conditions produce the fastest rate? Okay, iron powder at 50 degrees Celsius, iron pieces at 50 degrees Celsius, iron pieces at 25, iron powder at 25, iron powder at 35. Again, the best one would always be powder because it has the highest surface area. And then, okay, we have powder, but which one has the highest temperature? It's B50, right? So it's going to be A. For reactions to occur, exercise 3, the particles of the reactants must collide. Which of the following decreases the frequency of collisions? Breaking the solid into smaller pieces? لا. Raising the temperature of the reaction? لا. Decreasing the concentration? Yes. Right? Increasing the pressure if it's a gas, أكيد that will make it faster. Decreasing the temperature, there's more than one answer. Yeah, it should be two answers. Yeah, this and this. Okay. Explain why there's danger of explosion when a large amount of dry powdered combustible material is produced. I'm gonna go just show the answer. Okay, if it's a large amount of powder, okay, then since its surface area powder, and its surface area is so high that it might have an explosion. Okay, the reaction will be so fast and exothermic that an explosion might result. Explain why an increase in the concentration may cause an increase in the rate of reaction. Okay, blah blah blah. Okay, when you increase concentration, it increases the number of particles, right? As the number of molecules present, what did he say? Increase in concentration. Yeah, there will be more particles present, so there will be an increased possibility of collisions. Okay, when there's more collisions, any whatever increase in the rate, blah blah blah. Which of the following is the activation energy? Is it the maximum energy that the particles need to produce? No. It's the amount of energy used by the particles during a collision. I don't think so. I don't think it's B. The minimum amount of energy required by reactants to undergo collision. Yes. It's the minimum amount of energy which reactant molecules must possess for the effective collision in forming the products. I think so. But I think for some reason it's wrong. CQD 21, 25, 21. C 25 كمان. C. Okay, I don't know why D is wrong. Let me check. Okay, after looking it up, so this, okay, there's two types of energy. There's activation and there's threshold. So for activation, it's the energy to undergo a reaction, okay, to activate, okay, to do the reaction. However, threshold energy is the energy for the reactant molecules to possess for the collision. To do the collision, it has to be threshold energy, okay? To form a collision, for an effective collision, that's threshold energy. But to undergo the reaction, to activate the reaction, that would be the activation energy. So undergo reaction would be activation, but for the effective collision would be threshold energy, okay? Uh, uh, okay, okay, over here for CQD 19, I think they're gonna get something like this in the written or in the exams. Something like this will come 100%. Okay, what do the labels A to K represent? Okay, I'm gonna open the answer key. So, uh, you know, CQD 19. Okay, here A is the energy, right? So we can say A is the potential energy. That's an easy way to memorize it. B is what we call the reaction coordinate. Okay, I'm gonna put the answers side by side. Wait, hello. Okay, like this. Okay, for A would be potential energy. Okay, B would be the reaction coordinates, right? As it goes. C would be the reactants. And what am I starting off with? It's my reactants, okay? D is obviously the products. What am I left over with? Okay. Then E would be the energy of my reactants. How much energy do my reactants? So it would be what they call the heat content of the reactants. Okay. And then they put the value of it. You just look at the value. Okay. Then A, B, C, D, E, F. Then F would be the same. Heat content of this time the products. Okay. Let me erase a bit. Now let's take a look at G. G is the energy required for this reaction, for my reactants, to reach the activated complex. And what do we call that? The activation energy, but we call this of the forward, okay? Because there's two types of reactions. There's the forward, which is going like this, and then there's the backward, which is going like this. And we're going forward, so we say this is the activation energy of the forward. Then H would be, let's look at H. It's going from the products to the activated complex. So isn't this also activation energy? Yes, it is. But now we're going backwards. Okay, so we call this the activation energy of the backward. Okay, then A, B, C, D, E, F, G, H, I. I is the energy from the bottom all the way to the activated complex. So this is the energy of the activated complex. H, I, J. J is the difference between my reactants and my products. So what do we call this? Delta H, or you could say enthalpy change. Okay, whatever you want. Okay, you have to also give values whenever you can. Just find the value. How do you find the value? You just subtract this by this. H I J K. K is obviously the activated complex. Okay, is this calculate the values of E to J? E we said is, where's E? E, just look, 525. Okay, from here to here. E F, F is from here to here, so 175. E F G, G is from 525 to 788. But you just subtract. E F G H, H is from here to here. You just subtract. H I, I is from here, from 0 up to 788. J is from 525 to 175. Subtract. K, there's no K. Okay. Uh, the overall, is this exothermic or endothermic? We start at 525 and my products have 175. For the products have less energy than the reactants. فأكيد energy was released, so it's exothermic. Okay, the overall reaction is exothermic. Uh, this means because, why? Because you could say because the heat content of the product is less than the reactants, and delta H is obviously negative. Okay, delta H is negative. How do you find delta H? It's heat content of the products minus heat content of the reactants. When you have a graph like this, huh? Let me take this back into, hold up, maximize. Okay. Uh, question 20. Study the following potential energy diagram and answer what do. Okay, I'm gonna skip this because it's the exact same thing. Okay. Okay. Now the catalyst. Okay. Catalysts, it's important to know, catalysts don't do anything. Okay. What they do is they provide an alternative path that requires less kinetic energy. Okay, less activation energy. A good example I like to give. Okay, it's, imagine there's a store. Okay, and you have, it sells like expensive products. I don't know, say, well, jewelry. Okay, let's say it's selling jewelry, it's selling bracelets, a bracelet shop. Okay, and the bracelet shop, it's expensive, but it has all these bracelets for what, $1,000, $1,500. Okay, let's just say $1,000. Obviously, well, it's too expensive for some people. Okay, but you're gonna have some people buying, right? You're gonna have some people buying, but there are still gonna be a lot of people who won't buy because $1,000 for a bracelet, you know. For we go on and on, but then suddenly the bracelet shop decides to put a discount. Obviously, now when the bracelets, they say now, oh, we're gonna make the bracelets $500. Now everybody's gonna start buying it. Well, not everybody. There's gonna be a lot more people who buy it because there's a discount now. Think of a catalyst like a discount. Okay, it decreases the activation energy required. So basically, let's say I had a reaction that had an activation energy of 120. I would still have 10, 15 particles who make it through with an activation energy of 120. But what the catalyst does when it's added is it decreases the activation energy down to like 60. So this way now, there's going to be a lot of particles who have enough energy because it's 60. You know, everybody has 60 activation energy. Okay, for now, this way they'll all be able to react since they have enough activation energy. Anyway, an important thing to know is that there will still be particles who go through with the original price. Okay, So like with the same example I gave you with the 120 and 60 now, they would still be particles who go through with the pathway of 120 activation energy. So it doesn't completely delete the expensive way. It just creates an alternative pathway for the poorer particles. Okay, think of it like that. So a catalyst is a substance which enters a reaction to increase the reaction rate, but it's fine. Oh yeah, okay. One thing, one thing important. Okay, a catalyst takes part in the reaction, but it is regenerated. Okay, so it comes back. Okay, so it's not used up. Sometimes they ask you which is the catalyst. You have to look at the substance that was used up but came back, regenerated. That's what a catalyst is. It's never used up. Okay, for those who do bio, you should know enzymes are catalysts. You guys know that enzymes are never used up in the reaction. Okay, they always find their way back. Okay, a catalyst is a substance which enters a reaction to increase the reaction rate, but is finally regenerated, so it's not used up. We know, and catalysts are not used up. It lowers the activation energy and the heat of the reaction. Yes. Okay, it speeds up reaction without taking part in it. Yes. Enters the does it take part? I don't know. Uh, Enters the reaction to provide a path of lower activation energy. We know this. That's correct. Speeds up the reaction, but only small amounts of it are needed and consumed. I don't know about this one. Catalyst takes place but regenerates, so it's not used up. Okay. Let me put this into, because so far they're all correct, but let me check. Wait. Okay, فasked ChatGPT and ChatGPT just told me I'm wrong. Okay, the correct statement is only A. Okay, a catalyst is a substance what is regenerated, so it's not used up. Why are these inaccurate? B, a catalyst lowers the activation energy, but it does not change the heat of reaction. It doesn't change the heat of reaction. I remember my teacher telling me this. Okay, delta H stays the same. I think Kaman is mentioned here. Okay, a catalyst. Okay, yeah, it doesn't change delta H. Delta H remains the same for catalyzed reactions, okay? It's still the same energy being given off. Okay, so it doesn't change the heat of reaction. Okay, a catalyst does take part in the reaction mechanism, but it's not consumed. So do we say it doesn't take part in it? No, it does. But see, they try to trick you. It does take part in it, but it's just not consumed. Okay, so that's why C is wrong. And then D, it enters the reaction to provide a path of lower activation energy. ChatGPT is saying it's partially true, but it omits the fact that the catalyst is regeneration. So they didn't say that the catalyst was regenerated. Okay, فدي wouldn't be correct because they're supposed to say the catalyst should be regenerated. Okay, then E, a catalyst is not consumed in the reaction. It speeds up the reaction, but only small amounts of it are needed and consumed. Did we say catalysts are consumed? No, they're not. Okay, they're regenerated. I should open up my eyes. Where am I? Okay, I should open up my eyes. You should as well. Uh, Chemistry always try to trick you. A catalyst speeds up the reaction. How does it speed it up? Reacting with the reactants to form new products. Does it react? No, it doesn't, right? Replacing the mechanism of the uncatalyzed reaction with a new mechanism that has a lower activation energy. Does it replace it? No. We said it just provides an additional path, so it becomes two paths. Okay, so the catalyzed and uncatalyzed reactions proceed simultaneously. It has lower activation path. Yes. Slows down. أكيد لا. Provides energy to the reaction. So no, it doesn't provide energy. So it should just be C. A catalyst speeds up, okay, a reaction by lowering the activation energy of the forward reaction by increasing for the reverse. No, we know that it decreases activation energy for both the forward and backward. I think it's that somewhere. Uh, yeah, it speeds up both the forward and reverse. Okay, so first one is wrong. Both forward and reverse by lowering delta H? No, we said doesn't lower delta H. The forward reaction without affecting the reverse? No. All reactions by lowering the H reaction, head product, and delta H? No. Both forward and reverse reactions by lowering the activation energy of the forward and backward reaction? Yes. Okay. Question. Okay, there's so many questions. Okay, the catalyst for the reaction. Okay, they want you to figure out what the catalyst here. So we said the catalyst is used up, but it's regenerated. So let's see what's used up but comes back. Is it H2CO2? No. Is it H? H is used up here. Does it ever come back? Yes, it does. So my hydrogen ion is my catalyst. The graph below shows the differences in rate of reaction at different conditions. Okay, which would have a lower temperature? أكيد B. Higher concentration? أكيد A. Greater rate of reaction? أكيد A. Smaller surface area? B. Catalyst? أكيد A. Okay. CQD 15. Okay. In three different. Oh my god, bro. Okay. Which one has a lower temperature? Okay, let me zoom out. So lower temperature would obviously lower rate, so B. Okay, lower concentration of HCl. Is hydrochloric acid the limiting or the excess? Uh, same. Okay. Okay, I'm reading the question, but in the answer key it says that hydrochloric is not excess because here the answer is C. When they decrease the concentration of hydrochloric acid, the mass actually decreased. I think that means hydrochloric acid is the limiting, but it wasn't mentioned here that I can see any. Maybe it was. I can. I'm مش but I guess if it's not mentioned, then keep it as the limiting. A smaller surface area, أكيد it will be B. Addition of catalyst will be A. Okay. Okay, here just know that as you go right, the temperature's increasing. Okay. Okay, that's a lot. That's a lot. Okay. Give one possible reason why point X is not on the graph line. Uh, uh, Obviously because it's inaccurate. It doesn't fit the trend. I don't know how do they say it. CQD7. They say it in their own way, and I'm not gonna make up an answer. CQD7. Experimental error. Yeah, you can just say it's an error in the experiment. Whenever you have an inaccurate result, just say experimental error. What is collected after 20 seconds? Go to 20 seconds. 20 seconds, go to my graph. It's 30. How long does it take to collect 40? Go to 40. Go down. It's over here at 32, 32, 32 seconds, 33 seconds. Okay. Uh, how long does it take? Okay, when the reaction stopped, 1 gram of the catalyst was still left. What caused the reaction to stop? Obviously, all the reactants were used up. Yeah, the reactants were fully used up. Questions like these always come. Uh, uh, okay, okay. We'll go with them. Okay, sketch on the same axis. What happens? Okay, let's see. So a student used 10 gram of CoCO3 of 2 molar acetic. Okay, this is an excess at 60 degrees Celsius. Okay, for 300 centimeter cubes of 4M ethanoic acid. So they increase the concentration of the acid. Okay, and we know the acid is excess. So heat, since you increase the concentration of excess, the rate will increase, but the products formed will not. So it will be like this. Okay, I think we'll get something like this in our written. Be careful. So it will look something like this. Okay, we got A. Sulfuric acid. Okay, make sure, by the way, I mean, they might be picky with it. Make sure that they end at the same, like, okay, it doesn't have to be exact, but you get me. Sulfuric acid of the same volume and concentration was used. Label your graph B. Okay, it wasn't ever mentioned, but you're required to know that sulfuric acid is a strong acid. Okay, it's stronger acid. Okay, so instead of acetic, we used a stronger acid. فأكيد it will be a quicker rate. So it will also be here, B. The acid was cooled before the reaction. أكيد lower temperature, lower kinetic energy, lower rate. So this will be C. 10 grams of CaCO3 in the form of small pieces were used. We had powdered. Okay, please be careful. It was powdered. Now it's small pieces. Is the surface area decreasing or increasing? Usually when they put small pieces, everybody says, oh, higher surface area. But لا, it's lower because we had powdered. Okay, since it's powdered, it's gonna be lower. فهون دي كمان. Catalyst was used. أكيد it would be the one up here. Okay, faster. 12 grams of powdered CaCO3 was used. So we had 10 grams. Now we have 12 grams. So it will be more. So this is gonna be F. Okay. Option 9. Okay, at what time does the result appear to be inaccurate? I'm skipping to the questions because it's the same thing. Where is it inaccurate? أكيد at 2 minutes, right? How does the speed of the reaction change over the 6 minutes? You can say it increases and no, it decreases. You don't say it increases. We say it begins to decrease until it reaches 0 at 6 minutes. Okay, let's see. What do they say in the answers? Okay, part B. The speed decreases or slows down until it stops. This why? Because it's being never say the reactants. Yes. Okay, this occurs because the hydrochloric acid is being used up or becoming less concentrated. Okay, so you can never say the reactant is being used up. You have to specify what is being used up because sometimes if you say the reactant, it could be the excess or the limiting. And we know that the excess is never used up. It's always the limiting that's being used up. So you have to specify which is the limiting here. Okay, we know that zinc powder is the excess, yeah, that means hydrochloric acid is the limiting. So you have to say the limiting was used up. And what's my limiting? Hydrochloric acid. So you have to say the reaction decreases until it stops because the hydrochloric acid was used up. Okay. Part C, sketch on the graph what happened if it was repeated at 50 degrees Celsius. Again, I think they get a question like this. It's 25. Akid, if it's 50 degrees Celsius, it will be like this. Heck. Okay. Using excess lumps of zinc. Lumps. It was, I think, powdered here. It was powdered. Uh, excess. Yeah, it was powder. If you're making it lumps, yani the surface area is decreasing. But it will be like this. Okay. When did the reaction finish? It finished obviously at 6 minutes. 6 minutes or 5 minutes? I think it should be six. The reaction 3.7 minutes. 3.7 minutes here. How can you tell type? Wait. The reaction finished after 3.7 minutes. All the hydrochloric acid was used up. Volume of okay. طب I don't get it.
And the graph below was drawn using graph below answers the questions. In Sing A, at what time does the result appear to
No,
be
not A,
inactive?
not A, not A.
What?
D.
Oh yeah, D. D. When did the reaction finish? Why? First, they asked me when did the reaction finish. Uh, at so the reaction finished from 0 to 7. So we do 0 times 6.5.
Adam, go, يا
What?
أخي, go, go.
What?
Man, go, go.
What does she want?
Go. يا أخي, what are you saying, man?
What?
No, no,
I
no.
feel. Did you say anything correct?
No.
What do you mean?
شو خص zero?
Because you start. The 0 is the starting
No,
point,
no, no,
and
no.
here's number 2. We'll
No,
stop.
no, 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 no.
Why is it recording?
Huh. No, I'm not. Oh, Ya Allah, man. Okay, I asked in the group. Apparently, in the answer key, it's a different graph. Where you actually finish up. Yes, over here, they're in their graph. They have a different graph over here. 3.7 minutes over here. Like it stopped at 3.7 in their graph, but in our graph, it stopped at 6 minutes. Okay, it's fine. Explain using the collision theory why the reaction rate decreases. Okay, obviously when the react. Okay, I'm just gonna put up. As time passes, the initial concentration will decrease. Obviously, the initial concentration of what? You have to say of what. Okay, guys, you can't just be general and broad and say just the concentration. You have to say the initial concentration of what are we testing? Hydrochloric acid. Okay, so we say the initial concentration of hydrochloric acid decreasing, thus there will be less collisions, so the rate will decrease. Okay. Where am I? Where am I? What's the purpose of the gas syringe here? Obviously to collect the volume of the gas, to measure the volume of the gas, right? Okay, because I'm gonna skip this. Okay, لأنه it was in the quiz. Okay, did they ask for? Okay, why is it necessary to keep, let's just do it. For why is it necessary to keep the volume the same? Obviously for fair comparison. Okay, if the experiment is performed at 42, explain what happens to the rate of reaction. Here it's at 20. Here temperature will increase. So what will happen? There will be more kinetic energy since the temperature increases. Therefore, the particles move faster, and there will be a larger, more amount of particles that have activation energy. So there will be more collisions. Okay, more frequent effective collisions. So the rate of reaction increases, more kinetic energy move faster. There will be a higher frequency of effective collisions. Why does the cross on the paper disappear? Akid, because the precipitate was formed, right? Remember, why does this cross form? Because here, when the reaction happens, there will be precipitate formed. Okay, so due to the formation of the precipitate, yeah. Okay, experiment was repeated using 250. How would the results differ? Okay, here it was 100, but they used a larger beaker, so there will be more area for it to occupy. فأكيد there will be a lower rate. The time taken would be longer because the bottom side of the larger beaker would have a larger surface, so the precipitate formed has to spread out over a larger surface. As a result, longer time is needed for enough of the precipitate to sediment and cover the cross. Name the gas produced when you react hydrochloric acid with calcium carbonate. It's always going to be carbon dioxide. Okay, what is the role of the cotton wool? It allows the gas to escape and it prevents spilling, right? It allows the gas to escape and prevents the splashing. Okay. Why does the mass of the beaker decrease? So why does this balance here? Why does its mass decrease? Obviously, carbon dioxide gas will escape, so that means the mass will decrease. So it will release a gas. Okay. On the same grid, sketch the graph if it was used at 50 degrees Celsius. Here we're using 25. If we use 50 degrees Celsius, it's going to be faster. But since we're going down, it's going to be under. A faster graph would be under. So like this. How about if you use concentrated hydrochloric acid? So is hydrochloric acid the excess? No, it's the limiting. Since it's the limiting and we're increasing the concentration of the limiting, that means we're going to have a faster rate and we're going to have more product formed. So it's going to look like this under it, okay? Let me look at the solution. Okay, refer to the graph 5-ish. What's graph 5? 4, 5. Hold up. Why does it have the same? Why does it have the same? Increasing the concentration of hydrochloric acid. I just realized. In this case, okay, it's gonna stay the same. Okay, so why not like that? It's gonna there won't be more products formed. Only in this case. Only in this case. Okay, it's gonna يعني حتى for this one here, they're both gonna يعني be faster but end up at the same point, because here we're not talking about the product formed. No, we're talking about the mass of the flask. So we're talking about the mass of the flask over here. So we're talking about this here. Is this where the product is formed? No, the product is escaping outside, but the mass of the flask, it doesn't change, okay? That's why, okay, we're not talking about the product. If they ask product formed, then akid it will be more product formed, okay? But here the same mass of the flask. Okay, so they end up at the same point. I remember this came in the AMS. CQD12, the following apparatus is prepared for oxygen. What is the tube of the manganese oxide used? Why was it suspended in the flask? Okay, this is a catalyst. Manganese oxide is a Is this the last one? There's still more. Okay, the manganese oxide is the catalyst. Okay, why is it suspended? Because we want to prevent the reaction from happening. To prevent it, so they don't react with each other. What is the role of manganese oxide? It's a catalyst. Okay, it speeds up the rate of the reaction. Okay, blah blah blah. They explain it. How does it speed up the rate? It offers an alternative pathway with lower activation energy. Right? Okay. If 1 gram of lumps was used, what would happen? Here it was a powder. If we use lumps, that means it will be a smaller surface area. That means the surface area will decrease, so slower rate of the reaction. Okay. D. When the reaction stopped, 1 gram of catalyst was still left. Why? We know that the catalyst is not used up, right? Oh wait, what? D? Why did the reaction stop? Why did the reaction stop? Why did the reaction stop? Obviously, why does any reaction stop? When the mass of the limiting, or when the concentration of the limiting is fully used up. So here, hydrogen peroxide is our limiting, so hydrogen peroxide was fully used up. Okay, it was fully decomposed. How does the reaction start? How does it start? By shaking the flask or letting go of the so we have to open up this cotton string so that it can actually react. Okay, or shake the flask, whatever. Phosphorus burns air to give P4O10. The delta H is this. Draw an energy diagram for the net reaction. Explain the critical parts of the curve. How much heat is produced when 12.4 grams of phosphorus burn? Okay, I'm gonna do this because maybe they get it صراحة. CQD 23. So draw an energy diagram. Okay. The way you do it, I'm gonna take this into open board. Okay. فأول شيء write down your reaction. P4 is exposed to air and burns to give P4O2 أو 10. فأكيد it's P4 our reaction. It's burning in air, so يعني with oxygen أكيد to give P4O10. Let's balance it. أكيد is gonna be 5O2, right? So we know that delta H is negative, so أكيد is gonna be exothermic. It's gonna look something like this. Exothermic means the reactants have more energy than products. So this is the reactants, and the products will be somewhere here, right? And we know that it goes up and then it goes down, right? Okay, so what is our, remember, what do we start with? We say that here's the potential energy, right? Potential, uh, potential energy. Okay, and uh, we don't have to label the energies, right? No need. Yeah, no need to label the energy. Here always is the reaction coordinate. Reaction coordinate. Okay, we know here is always our reactants. In this case, we can't write reactants. We have to write what our actual reactants are, which is P4 plus 5O2, P4 plus 5O2. Then here we put our products, which is P4O10, because this could come up. Okay, and they said delta H is minus 1, 2, 3, 2, 1. So how do they do it? Okay, yeah. Okay. Minus 1, oh, yeah, delta H. Yeah. They want you to label everything. Okay, yeah. For delta H to show delta H, you just put it you just put an arrow between your reactants and the products, because you know delta H is the difference between the energy of the heat content of the reactant and the heat content of the product. So you're gonna put this and you're gonna label this delta H. صح? Is that how you put it? Yeah, delta H. But put it outside. Okay, just say delta H. You know what? Don't write it like this. Put it label like make the label a bit bigger. Just put it like this and say delta H. Then let's label the activation energy. Okay, explain the critical parts. Critical parts, yani the activation energy. So we can put this over here. We can say this is activation energy of forward, right? You have to mention that it's the forward. Okay, then this over here from here to here, you could it wasn't mentioned, but I would prefer to say it. This is the activation energy of the backward. Yep, I didn't say of the backward. Okay, what can we label? We can label more. We know this is the heat content of reactants, and then this is heat content of products. What else can we label? We could say this is the activated complex. I think that's it. What did I do? No, previous. Oh, okay. Yeah. I mean, there's nothing else I could say here. Yeah. Okay. Given the following potential energy, identify A, B, C, D, E. Obviously, A is the reactants. B is the activation energy of the forward. C is the activated complex. D is the products, and E is delta H. Is that correct? Oh, there was part B. How much heat is produced when 10.4 grams of phosphorus is poured? Okay. Uh, how do they know? Okay. P4. This is our reaction. P4 plus 5O2 produce P4O10. Okay, and it releases. We said it releases 1, 2, 3, 2, 1 kg, right? 1, 2, 3, 2, 1, right? Kilojoules, whatever. Let me move to the right. Kilojoules. Then the molar mass of P4 is 124. You can get this from your periodic table. So we can do RR and GR, right? So we our P4 here they said 12.4 grams of P4. So our given is 12.4. But what's in my reaction P4? How much is P4? Here we have P4. How much is it? The molar mass 124. So how much energy will I have in my reaction? I have 1, 2, 3, 2, 1. So okay, here I will have cross multiply x. You're gonna get x equals 1, 2, 3, 2.1 kilojoules. Okay. Uh, okay. Give the effect of adding a suitable catalyst on B and E. Okay. We know when you add a catalyst, delta H doesn't change, right? What only changes? The activation energy. So the only thing that will change will be, and we know that the activation energy will become lower. So B will decrease. So B decreases while E stays the same. Okay. Uh, okay. Which of the following just describes the change of condition between the two experiments? The temperature in B is higher than A. أكيد no. Granulated calcium carbonate is used in B. but powdered is used in A. أكيد A has the faster reaction فأكيد it will have higher surface area. So this is correct. B is correct. A catalyst is added in B. يا الله. A catalyst is added in B. أكيد no. B doesn't have a catalyst. It's slower. The mass of calcium carbonate consumed in A is greater than B. Is it the excess? No. No. Okay. We know calcium carbonate is limiting. But if the mass is greater in A, then it would have more products formed, but they have the same amount of products formed. So no. The mass of calcium carbonate used in B, this is wrong, is greater than A. Okay, this is wrong. So I think the only correct one is B. Yeah, 27B. 28. Yeah. Okay, which is true about the reacting particles. Okay, the collision. Okay, the rate can be by. Okay, the collision rate of particles stay. Okay, when they increase the concentration of the hydrochloric acid. Uh, the collision rate of particles stay the same. The proportion of obviously if you increase hydrochloric acid, the collision stays the same. Obviously wrong. There will be more collisions. The proportion of particles with sufficient energy to react decreases. That doesn't really make sense. We're increasing concentration. There's nothing to do with energy. The collision rate increases. Well, yes. The proportion with sufficient energy increase. No, we didn't really say anything about energy. We're talking about concentration. But 28 should just be C. Yeah, C. 3 only. 29. How does a decrease in temperature decrease the rate of reaction according to collision theory? Okay, So temperature. What happens when temperature decreases? Obviously, collision rate will decrease, right? But will the proportion of particles with sufficient energy to react will it stay the same or decrease? Akid, since the kinetic energy will be decreasing when you decrease the temperature, then the proportion of particles with sufficient energy will decrease. Okay. 30. Oh my God. How many more? Aha. Okay. Uh, a student. Okay. The student uses collected data and okay in order to describe. Identify the measurements x and y taken by the students and used for the graph. Okay. ف So basically, he wanted to measure the rate, right? And in the graph, obviously, always here it would be the time. Okay, you could say time in minutes. Okay, the time. It's always the time because time goes to the right. Yeah. Okay. How about measurement y? What's measurement y? Y. How do we measure the rate of any reaction? We measure something from the reaction. In this case, what's the best way? It's always best to measure the gas. So here we could say measure the volume of the gas, and the volume is the volume of what gas? Sorry, it's the volume of hydrogen. Okay, so the volume of H2. It's the volume of the gas released. You could say hydrogen gas, you could say gas, whatever, still the same. How does the rate of reaction change as the reaction proceeds? Okay, the reaction begins to slow down until it eventually stops because the concentration of uh, hydrochloric acid ran out. You can't see the concentration of the excess ran out, it has to be hydrochloric acid. So the rate decreases, gets slower because the concentration of the acid decreases, leading to fewer collisions per unit time. Okay. Okay, explain. So always go the extra step. Don't just say because concentration of acid decreases. Explain. Okay, top concentration of acid decreases, then what happened? That means lower collisions. Okay. Another student performs the same experiment at a lower temperature. What is the impact of this change on the rate of reaction? Okay, if it's a lower temperature, then it will have a lower rate of reaction. Explain the change in terms of rate of collisions. Okay, their rate will decrease. Why? Because they have less kinetic energy, so the particles will move slower. Okay, blah, blah, blah. Just say they have less kinetic energy. Okay, so that means there will be less probability of effective collisions. Okay, what's the effect of using smaller pieces of magnesium on the rate of reaction? Okay, here we have big ones. Okay, if we use smaller pieces, okay, there will be high surface area, so higher rate. Okay. Ugh, what am I do? What is this? Whoa, 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 whoa. So I'm looking at the past paper. I'm gonna do the top. Okay. Then for the past paper questions, I'm gonna leave a link in the description for every past paper question solved on YouTube because people solve these IGCSE questions. Okay. I'll leave a link for all of them in the description one by one. Okay. Uh, anyway, let me go back up here. Hold up. Okay, if it's an experiment, okay, these experiments, blah 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 blah. So here they just want you to read yani. Okay, you have initial and you have final. How do you calculate the average? I guess you just add and divide by 2, so it should be 8 and 19. Here it should be uh, 29. Here it should be 44. And here it should be 49. No, I think. Then for the time, you just read it yani. Okay, time. So they want it in seconds. Here we have, this is the minutes. We have 1 minute and 10 seconds. So I think 1 minute and 10 seconds is 70 seconds. Then here you have 0 minutes and four, wait, 0 minutes and I think 50 seconds. Well, what's this? 45 is 50, 55, 6, 57, 57. And then this one over here. Okay, hold up. This one here, it's 0 minutes and 32 seconds. The seconds over here, 32. And then here it's 20 seconds. Yeah, 20. Okay. Then draw a smooth line graph. I'm just gonna open up the answer key, man. Uh, Now, for part B, to graph, you just need to take all the points from here. Temperature versus time. Okay, so at what's this average temperature? Let's take the listings. At average temperature 19, we got time 70. So let's go to average temperature 90 from the table here, huh? From this table over here. So let's go to average temperature 19, which is over Let me zoom in a bit. Should be over how many squares? 2, 4, 6, 8, 10? 10 squares? 10, yeah. Okay, 5 is 0.5, so it should be over here. 19 over here, and we said how much? 70, right? 70 seconds? 70 seconds. 1975. Let me go up to 17. You know, I'm gonna put this in the open board. 1970. 70 is over here. It should be one sec over here. Okay, always remember to put an X in your graph. Okay, if you don't put an X, you won't get the mark. Then what do you want? 29, 53. If we go to 29, okay, 29, 53 over here. Is this 10 spaces? It's 2, 4, 6, 8. Yeah, so here 53 will be 1, 2, 3. Should be over here. Oh, why is my screen okay? I'm getting. Whoa, my screen's shaking. 44, 32. Okay, 44. So I go to 44 over here, 32. So over here, 44, and over here, 32. My God, my eyes. My eyes over here. Okay, and then 49, 20. Okay, this should be easy. This one, 49 over here, 20 over here. Remember to put an X for every point, okay? Then I think you just connect. They just drew it. Okay, yeah, you just connect them. Okay, please, if you're graphing, use a straight line now. Sorry, use a ruler and use pencil. Don't forget. So here, let's connect it. Let's connect these points. It should be any form of straight line, somewhat straight line. Let's connect. Yeah, I mean it's close. I won't be using this graph to answer because any as on computer. On paper, obviously you'll have a way more accurate graph. Okay, so see here, they connected them. They want for part C, use your graph to see the time. Sorry, to reduce the temperature after 60 seconds. So you go to your graph. You want to go to 60 seconds. So you go to 60 seconds, and you see where it touches the graph, which is over here. And you want to see what point is this? So you go down to the temperature over here, 26 seconds. Okay, that's how you find it. So 26 seconds from your graph. There's no exact answer. It always depends on your graph. Okay, if the corrector will check what's the answer on your graph and see if that matches the answer you wrote down. Identify the experiment at which the rate of reaction was lowest. Explain your answer in terms of kinetic molecular theory. We have 4 experiments over here, right? One was done at this temperature, one was done at this temperature. Obviously, the one that's the slowest was the one with the least temperature. It's going to be experiment 1 because it had the lowest temperature, and then they said explain it. Why? Since it has the lowest temperature, that means they have the least kinetic energy, so they move slower, so less frequent collisions. Okay, give some sort of explanation. It doesn't have to be 10 out of 10 explanation, but give an explanation. So you say the one with the lowest temperature because they have less kinetic energy, so they move slower, so there's less frequent collisions. Okay. E. A student added HCl to sodium thiosulfate using a pipette instead of the measuring cylinder. Would you recommend this step? Explain. Uh, okay. I mean, if this comes, put this. I don't think this will come. If it comes, say it's not good to add a pipette because pipettes take longer time. Okay. It would be slower. It would be slower if you use the pipette. The use of pipettes or burettes to measure volumes of solutions used in these experiments would improve the accuracy of these results. Suggest another way to improve the accuracy of these results. Usually insulation or use a lid to reduce heat loss. So this experiment here. Okay. Well, if you read the experiment, I doubt they'll get this صراحة. But if you read the experiment, it's something to do with heat. Another way to improve is to use a lid. Okay, so cover your solution so that not all the heat is lost. Because now what are we measuring? We're measuring the temperature. So to get a more accurate temperature reading, put a lid. So yeah, هلا past papers. I'll put the link for every past paper question in the description and the timestamp for each video. That is the last recording of grade 10. thank you so much for your support over these 6 months. I enjoyed every single recording, even when sometimes I wasn't in the mood. And really, I like explaining, and inshallah, when I grow up, this made me want to become a professor when I grow up. Seeing, many people benefit from just something that takes me little effort is, it makes me happy. Thank you so much for watching. Thank you so much for your support. I really couldn't have done it with you guys without you guys. Um, and for one last time, until grade 11, thank you so much for watching, and good luck in your exam.